Let me begin with a simple thought. Suppose you and your friend both have some money. You have 5 rupees and your friend has 8. Instinctively, you say 5 is less than 8. That, my friends, is an inequality. Unlike an equation where both sides are equal, inequalities express relationships where values are not equal. We use these 4 mathematical symbols: less than, written as angle bracket opening to the left; greater than, written as angle bracket opening to the right; less than or equal to, written as angle bracket opening to the left with a horizontal line beneath it; greater than or equal to, written as angle bracket opening to the right with a line beneath it. In this chapter, we'll learn how to use these signs to compare values, solve inequalities algebraically, and represent solution sets using set notation and number lines. Let's begin. When we say A is less than B, we write it as A angle bracket opening to the left B. This means the value of B minus A is greater than 0. Let's take some examples. 2 is less than 7 because 7 minus 2 equals 5. And 5 is a positive number. Now try negative 5 is less than 2. That's because 2 minus negative 5 equals to plus 5, which is 7. Again, positive. Even with fractions, the rule holds. 2 divided by 3 is less than 4 divided by 5, because 4 divided by 5 minus 2 divided by 3 equals, first, convert both to a common denominator, that's 12 divided by 15 minus 10 divided by 15, which equals to divided by 15. And since 2 divided by 15 is positive, the inequality is true. So always check, is B minus or greater than 0? That confirms A is less than B. Now let's explore A is less than or equal to B. We write this as A angle bracket opening to the left with A line below it B. This means B minus A is either positive or equal to 0. Let's test it. Negative 3 is less than or equal to 5. 5 minus negative 3 equals 5 plus 3, which is 8. 8 is positive. Let's try equality. 2 divided by 7 is less than or equal to 2 divided by 7. That's because 2 minus 2 equals 0. And 0 is allowed in this case. This inequality allows for both comparison and equality. So if B minus A equals 0 or is greater than 0, then A is less than or equal to B. Let's flip the scenario. What if A is greater than B? We write it as A angle bracket opening to the right B. That means A minus B is greater than 0. For example, 7 is greater than 2 since 7 minus 2 equals 5. 5 is positive. Let's try a negative pair if negative 2 is greater than negative 5. Negative 2 minus negative 5 equals negative 2 plus 5, which equals 3. That's also positive. What about fractions? 4 divided by 5 is greater than 2 divided by 3 because 4 divided by 5 minus 2 divided by 3 equals 12 divided by 15 minus 10 divided by 15, which equals to divided by 15. Since this is positive, the inequality is true. So always check, if A minus B is greater than 0, A is greater than B. Now for the final algebraic inequality, A is greater than or equal to B. We write this as A angle bracket opening to the right with a line below it B. This means A minus B is either greater than 0 or equal to 0. Let's try examples. 5 is greater than or equal to negative 3. That's because 5 minus negative 3 equals 5 plus 3, which equals 8. Clearly positive. Now try 2 divided by 7 is greater than or equal to 2 divided by 7. Because 2 minus 2 equals 0, and 0 is acceptable here. So, the condition holds if a minus b is either 0 or a positive number. Now let's visualize these inequalities on a number line. Let a and b be points on the number line representing values a and b respectively. If a is less than b, point A lies to the left of point B. If a is less than or equal to b, then point A is either to the left of b or exactly at the same place as b. If a is greater than b, then point A lies to the right of point B. And if a is greater than or equal to b, a is either to the right of b or at the same location. This number line view helps solidify our understanding. Refer to the diagram with horizontal arrows and labeled points A and B from the PDF for visual clarity. Alright, let's wrap up. We've seen how inequalities help compare values using 4 signs: less than, greater than, less than or equal to, and greater than or equal to. We learned that the difference between the numbers either b minus a or a minus b tells us if the inequality is true. We explored real number examples, integers, negatives, and fractions, verifying if the difference was greater than 0 or 0 itself. Finally, we used number lines to visually show these relationships. Inequalities are a basic but powerful tool for defining solution ranges and conditions in algebra. And that's our foundation of comparing real numbers using inequalities. In the next video, we discuss linear inequations, how to solve them algebraically, express their solution in sec notation, and graph them on the number line. See you there.